how come I say that it's a drawback? I do not know how many of you follow all this investment thing, okay? So for those of you who work in the industry, of course you must know something about it. But let me tell you what's going on here. Okay? There is a lot of investment firms in the world. They have the following guideline all the time. Usually they divide the asset into three groups: cash, bonds, and stocks. This is usually the three groups. And then bonds also considered as lower risk, but also lower return. All right? Understand it? Now cash is the except inflation risk, there should be no risk whatsoever. Okay? So it's the lowest return and also no risk whatsoever because we don't think about inflation. Inflation is a macro problem, not a micro problem. All right? Now they say, Rory, if you are in your 30s, you should put 10% in cash. 30, I just make it up, okay? 30% in stock bonds and 70% in stocks. I just make it up. No, sorry. 60% because they add to 100%. Now, if you are in your 50s, you should have 20% of cash. You should put 40% in bonds. You should put 20% in stocks. Is that right?
Shouldn't it be 40?
40, thank you. 40%. All right? Finally, if you are in your 60s, you should hold 25% in cash, 45% in bonds, and then 30% in stock. You hit it all the time. Agree? This does not satisfy the mutual fund separate theorem. Because according to the mutual separate theorem, the ratio of bonds to stock should always be the same. But they are not. Okay? And this is what is suggested by all these Goldman Sachs, Merrill Lynch, whatever, all these big firms. All right? But this is the recommendation, which is not consistent with our mutual fund separation theorem. That's why it's a drawback. Okay? And in the real world, a lot of people actually follow the advice for the firms. So they actually do not fulfill it. Okay? So that is the drawback. All right? Now, for those of you who have studied intermediate macro, some of you may have used the textbook Mankiw. Okay? Mankiw was a Harvard professor. He was the advisor for President Bush, I believe. The younger Bush, okay, not his father, younger Bush. He was Harvard professor. He actually wrote a paper. I put it in my syllabus. If you are interested, read it. It's called asset allocation, okay, model. He spent quite a few pages talk about how to rationalize the behavior of the firms and the real world. At the end, they say that they just cannot rationalize it. Okay, so it's a puzzle in finance. All right, is it clear? But that is the mutual fund separation theorem. Okay, and it's very likely that you will see it. Okay, in the final. All right. Okay, I only have 20 more minutes. So let me talk about page 59. All right. Mean analysis is very popular. All right. The idea is because they simply say that variance go up means that risk go up. This is so clear cut. All right. But what if, okay, we don't use mean variance analysis? Then we cannot say this anymore. So what is the meaning of increasing risk? Okay, what is the meaning of risk goes up? All right, is it clear? So people know that there's something wrong with the mean variance analysis, but until we have an alternative theory, we have to use it because we don't have alternative. Okay, is it clear? Remember that it's always very easy to criticize other people's theory. It's not realistic, it's no good, whatever. But what is the alternative? So before you have the alternative, it makes no sense, okay, to criticize it, okay? Is it clear? All right? Now the worst thing to criticize is that, oh, the model is not realistic, the assumption is not correct, okay? I remember that when I defend my thesis, I have 3 professors in my committee. One of them is actually a math professor, okay, because of a minor in mathematics, okay. And then they sat there. The professor asked me questions. Then the math professor, he know nothing about my thesis, okay, nothing about my thesis, okay. Of course, he knows the math, but my math, from the economist point of view, is quite sophisticated. But from a mathematics point of view, it's very, very simple one, okay. For him, it's nothing. But then he could not sit there and do not do anything. So he asked me some question. The question he asked me is that, okay, Manlui, my name, what happened if you relax this assumption? Okay, of course, I was so nervous, okay, but I have to smile, okay, you know that, you have to show that you are confident. In my heart, when he asked that question, I'll say that, stupid question. Of course, I could not say that, but it was a stupid question. If I knew it, I put it down in my thesis already, okay, because I did not know it, that's why I did not put it down. They asked me that, okay, so I just have to say something, okay, I say it for 20 minutes. I have no idea what I'm talking about. Okay, I don't think anybody in the room knows what I'm talking about either. He definitely did not understand what I said, but he then just said he gave up. Okay, and then I passed. All right, because he just had to say something. Okay, and my advisor did not say anything because he also know that it's a stupid question because he's a mathematician. He did not know how we do things in economics. All right, but anyway, Rothschild and Stiglitz wrote a paper in 1973 to define conceptually what is meant by induced risk. This is a very important paper. By the way, Stiglitz was Samuelson's student. Okay, he was also a Nobel Prize winner. Okay, some people say that he is a small Samuelson. He is not as great as Samuelson, but it's close to it. He also worked in a lot of field of topics. Okay, very smart guy, of course. He was also the president of the World Bank for a few years. Okay, he also advised to, I don't know, I thought maybe Clinton, okay, President Clinton, whatever. Okay, Rothschild is also a very famous economist, but not as famous as Stiglitz. All right, but anyway, they asked a very simple question: what is a random variable more variable or riskier or more uncertain than another variable? All right? So they want to formally define what is meant by more random, riskier. All right? Is it clear? So they have 4 answers. The first one is from the engineering point of view. We say that y is equal to x plus some noise. Noise always means random. Once you hear the word noise, you know that it must be from engineering. Only engineers talk about noise. We say that y is distributed, this d is distributed, x plus c. C will be a random variable. On average, is equal to 0. Okay? This is the conditional probability equal to 0. All right? For example, suppose I tell you that x is a lottery. All right? So that there is P1 probability, you get A1. P2 probability, you get A2. And P3 probability, you get A3. Of course, the sum of P1, P2, P3 is equal to 1, obviously. This is the first lottery, called X. Now what is Y? Why say that? Okay, if there is a P1 probability, you get A1. P2 probability, you get A2. But then there's P3 probability that you get another lottery. With Q1 probability, you get A4. Okay? And then you get Q2 probability, you get A5. And the mean AQ1, A4 plus Q2, A5 is equal to A3. That means on average, you get A3. All right? So do you see that? If you do something, okay, earlier, you either get A1, A2, A3. But now, if you go to the bottom one, you get another lottery. On average, you get to A3. So do you see that there will be more randomness there? That is the idea of x, y is distributed x plus c. Okay? This is the first definition. Well, of course, x and y have the same mean. Because the average of this is equal to A3. This is the first definition. Engineering. Y is distributed x plus c. Another definition is our definition. If there are two random variables, I say that y is more risky or riskier. All right? Is for every risk-averse individual, they rather have x instead of y. If not some risk-averse individual, is all risk-averse individual, they rather have x than y. Then intuitively, y must be riskier. Because risk-averse individuals intuitively do not like to take risks. Is that right? But mathematically, what is meant by all risk-averse individual? That means for every concave utility function. Because concave utility function is risk-averse. All right? You guys, everybody is risk-averse. And every one of you have a concave utility function. But every one of us will pick x rather than y. So the expected utility, this is the distributed, okay, it must be bigger. This is the second definition, our definition. All right? Is it clear? Number 3, this is from the statistics definition. X have more weight in the tails than x. Imagine, originally, this is the density function. Of course, the area under the curve is equal to 1. You know that. Okay? All right? Now, any shape doesn't have to be this shape. It can be this shape, whatever, doesn't matter. Okay? Any shape is fine. All right? Now, I have something called the mean preserving spread. What happened is that I move something from the middle to here. I move here to here. All right? Do you agree that if this one has certain mean, this one can have the same mean as well? Understand it? Now you understand that if I only move something from here to here, the mean must go up. Agree? But I move something to the right hand side, but I also move something to the left hand side, it balances out. This is called a mean preserving spread. All right? After I add these two together, this is what's going on. Okay? I move some weights here to here. I move some weights here to here. And these will have the same mean. But then intuitively you can see that this will be riskier than before. Is that right? Because I have bigger chance to go to the two ends. This is the statistic definition. Y has more weight in the tails than x. All right? Now, number 4. Y has a greater variance than x. This is the traditional definition, which is the definition in finance. But the same mean, if variance y is bigger than variance x, then we say that y is riskier. This is the standard definition of finance. All right? So Warshaw and Stiglitz have these 4 definitions. All right? Now the next concept, let me explain to you. Something called a partial ordering. A partial ordering on a set is a binary, transitive, reflexive, anti-symmetric relationship. Okay? All right? Okay, but let me explain to you what it means. Okay? First of all, what is meaning of a binary relationship? Such a relation between two things. All right? For example, I can say that these bits may mean taller than. So when I say A less than equal to B, that means A is shorter than B. Okay? Is it clear? Or it can mean smarter. So B is smarter than A. All right? Is it clear? Now all this can be quantified. But it doesn't have like that. How about this thing? Actually means friendship. So A is a friend of B. And this is a relationship. So this is a relationship. So good? Alright? This is called a binary relationship because it's comparing two terms, two things. Alright? Is it clear? Again, it doesn't mean be taller, shorter. It can be friendship. Okay, all right, or whatever. Okay, transitive is if A is less than, I will use the word less than equal to, but I don't have to mean that because I have A, B are friends or whatever. Okay, so A less than equal to B, B less than C, then implies A less than equal to B, C. Is that right? This is called transitive. Now you need to know that if the relationship is friendship, it doesn't work. Agree? So friendship is not transitive. Why? I am a friend of Ken. Ken is a friend of Jasper, but I don't even know Jasper. Okay, is it clear? So friendship does not work. So friendship is not a transitive relation, but taller than, shorter than, etc., etc. Yeah, they are transitive. Reflexive, then A less than equal to itself is called reflexive. Anti-symmetric means that A less than B, B less than equal to B, then A is actually equal to B. Alright? Is it clear? So a partial ordering is finally transitive, reflexive, anti-symmetric. But what is a complete ordering? Complete ordering, first of all, must be a partial ordering. But we also know that if A and have two things A and B, either A is less than equal to B or B less than equal to A. If I have that, that is a complete ordering. Okay, is it clear? So good? So now, another definition. So I have the less than equal to A. This is the definition for the engineering. Y this with X plus C. I say that Y is X is not is less than equal to Y. Y is riskier. The second one is I. I is for the MPS, the statistics. And then this U, utility. Alright? This is the definition. Now the most important conclusion of this paper is that first of all, the engine definition, the economics definition, the engineering definition, statistics, engine, economics, they are all partial orderings. But they are not complete orderings because there's something that you cannot compare. Alright? But then, important thing is that they are equivalent. That means if statistically Y is riskier than X, then we can say that Y is a MPS, okay, mean percent from X. That means you just get it, or everybody, every risk-averse individual will prefer X to Y, every risk-averse. So they are actually equivalent. Alright? That means the statistical definition, economic definition, and engine definition, they are constantly each other. Okay? However, the variance definition, it is a complete ordering. I can always compare any two assets, but they are not equivalent to the other three. That is, it's entirely possible that this asset, variance Y, is actually bigger than variance X. So that from the variance point of view, Y is riskier. But you can find some risk-averse individual, actually, they prefer Y to X. There exists some risk-averse individual who actually prefer Y to X. Okay? So this paper basically say that the mean-variance analysis is not appropriate. So that's why it's a very important paper. Okay? It tells us that this variance comparison is no good. Okay? Is it clear? So good? Alright? But then, of course, I said earlier, it is so easy to say something is no good, but you have to have an alternative. So that's why later on, which we will not talk about, because we don't have time, Rothschild and Stiglitz write another paper. Actually, they have two papers. It's called Increasing Risk 1 and 2. The second paper actually say that, okay, how to do compare statics, okay, by the so-called increasing risk. Okay, that is a very paper. Okay, but let me show you this. You go by the syllabus if you are interested. These are the paper. Okay, Rothschild and Stiglitz. increasing risk, a definition 970, and then 971. Increasing risk is economic consequence. Okay, if you are really interested. But the point is, these two papers are very, very mathematical. It took me 2 weeks to read the paper. When I say 2 weeks, I mean 7 days. Okay, 12 hours a day. It took me 84 hours to study the paper. And I still don't think I fully understand all the proofs. All right? Is it clear? But if you're interested, look at it. Okay? All right? Okay. So now let's see what else can we do. Okay? So I think I'm not going to do anything more. All right? So you can forget about everything that I do not discuss. Okay? In the lecture notes. Everything I don't discuss, you don't worry about it. Oh, no. I want to do one more question. Okay? All right? I lied. This is the last page for sure. This is a very interesting question. A risk-averse individual allocates his unusual wealth on 2 risky assets whose value next period per dollar invested is described by identical and independent distribution. All right? If you have studied econometrics before, a lot of you have. It's called the IID. Okay? Independent and identical distribution. You are a graduate student, you were taking econometrics as an undergrad. Okay? And then assume that the individual wants to maximize his expected utility. Now the question is, how should he or she allocate his initial wealth among the 2 risky assets? All right? Please make sure you know that there's no utility function. I only tell you that this is a risk-averse individual. All right? So now let's see how I do it. When you do something like this, all right, the way I do it is I'm going to form a conjecture. I just use my intuition to guess what the solution should be, and then prove it. This is a very common way to do analysis in economics or mathematics. Intuitively, because the 2 assets are identical and independent distributed, they're actually the same asset. So because the same, I expect that since the 2 risky assets have the same distribution, the investor will allocate equal amount to the 2 assets. Does it make sense? Since these 2 assets are identical, so there's no reason why I put more in one and not the other. So this is my conjecture. And then I will prove that it's the way we do it. So let's see what's going on. So I define W0 is my initial wealth. E1, E2 are the risky assets. So alpha is the proportion I put in E1. So I put alpha into E1%, or 1 minus alpha I put into E2. All right? Now I define Y alpha is equal to alpha W0 E1. Remember that this is the risky asset. All right? So alpha times W0 is how much I put into the risky asset. And each dollar give me E1. And this E1 can be positive, can be negative. Understand it? So the green vein is how much I get from the first asset. And the blue vein, of course, is how much I get from the second asset. This is when I put alpha, okay, percent into 1, and 1 minus alpha into 2. All right? Now, if alpha either 1/2, then of course it will be, if this is 1/2, 1/2, I get W0 over 2 E1 plus W0 over 2 E2. Is that right? Okay. Now, let me do the computation. So, now I have Y alpha minus Y 1/2. That is, I have the yellow minus the green. Okay? Now I see a E1 here, I see a E1 here. So I pull out the W0 E1. So I get the first term. Do you see that? I have the E1 and W0, I pull the function out. And similarly, this one I have W0 E2. W0 E2. I pull out, I get this way. Alright? Okay? And then this thing become 1/2 minus alpha, is that right? 1 minus alpha minus 1 over 1/2 become 1/2 minus alpha. That's the algebra. And then I see that there is a W0, and these terms are actually the same, except that they are opposite in sign. So I pull it out, I get W minus 1/2 W0, E1 minus E2, all this is algebra. Okay? Then the next step, I'll move this term to the right hand side so that I get Y alpha, which is equal to Y1/2 plus this term. Okay, because it's negative. When I put here, become Y1/2, that's what I have. Alright? Note that what is the expected value of this one? Is equal to alpha minus 1/2. I take the expected value, write this. Okay? The expected value, write this. Of course, I get alpha minus 1/2 W0. Expectation of E1 minus expectation of E2. But these two are same asset. Same distribution. So this will be equal to 0 because E1 and E2 have the same distribution. Alright? So what does it mean? Y alpha is equal to Y1/2 plus some uncorrelated noise because the expectation of this term is equal to 0. So Y alpha is equal to Y1/2 plus some, this is an uncorrelated noise because the expectation equals 0 for all alpha not equal to 1/2. Alright? From the definition of increasing risk, Y alpha is equal to Y1/2 plus more noise. So Y alpha must be more risky. Using the first definition, engine definition, Y alpha is Y1/2 plus some noise. So it must be riskier. Alright? So hence, every risk-averse individual will prefer Y1/2 to Y alpha. Alright? Is it clear? Because Y alpha is equal to this plus some noise. So this must be riskier than this one. Alright? And every risk-averse individual always will pick the one which is less risky. So everybody will pick Y1/2. So we prove it. Alpha maximize the expected utility. Okay? Is it clear? Alright? Now, please read it carefully. It's not alpha equal to 1/2 times less than 2. You want to use a bracket. So alpha equal to 1/2 maximize the expected utility. So this is the proof that if I have two assets, I will do it like this. Okay? Is it clear? Let me ask you the last question. I know you want to have a quiz. If I have three assets, which are all of them are equally IID, identical, and independent distributed, how should I allocate my asset? Intuitively. Three assets. How? If I have two assets, I should allocate it equally between these two. If I have three assets, I should allocate my money equally among the three. Okay? Is it clear? That is the intuition. So it's good. The proof will be much more difficult, but that is the intuition. Alright? Okay. We'll start our quiz at 6.